So here's a demonstration of the proportional component of my PID controller. So with the motors on, you can see that if the quadcopter is tilted out of the orientation that it wants to be in, which right now is level because my hands are off the controller, it's going to have a reaction proportional to how far it is away from its desired orientation. So in other words, the greater the angle becomes, the stronger the propellers, or the stronger the power of the motors. For demonstration purposes, I've only uploaded the integral portion of the PID controller, just to demonstrate how the integral portion would work. So the integral portion of a PID controller is really only concerned with how long the object is out of its desired orientation. So as you can see, the propellers are speeding up the longer they're out of level. As I bring the quadcopter back to level, or the controllers will say about, the motors would say about even power. The power won't change to each motor. And as I would invert it the other way, the motors will slow down because the integral value is dropping back down to 0. And you'll see the other motors start to speed up because these have been out of their desired orientation. For demonstration purposes, I've uploaded the derivative-only portion of the PID controller, and so what the derivative portion asks is how quickly are you moving away or towards the desired orientation. So right now I have pitch, roll, and yaw at 0, and pitch and roll at 0, and yaw and thrust at 0. So I'll increase thrust. I'll increase thrust. So now they're all spinning at about the same speed, and so the derivative controller is asking how far or how quickly am I moving away from the desired orientation. So it doesn't mind that roll. Right now all the motors are spinning about the same speed, even though roll is deflected sideways because it's not moving towards or away. It has no rate of change towards or away the desired orientation. If I let go though, you can hear the motors speed up as to counteract its the quadcopter moving towards its desired orientation. Also, if I move it quicker, so in other words, quick motions will result in a larger reaction from the quadcopter. Also comparable to tilting it sideways. It's harder to notice because I can't twist it quite as quickly. But you might be able to hear the change in RPM. So right now it's about level, so all the motors are spinning at about the same speed. As the quadcopter is tilted, the proportional reacts immediately and the integral reacts over time. And then right there, because I don't have it tuned quite right, it gets into about a natural frequency. And that's the derivative reacting to, so when you saw the oscillations back and forth, it was changing, the rate of change in the roll axis was fairly high, so the derivative part of the PID was reacting fairly quickly, and it got into its natural frequency, which is kind of cool.